All right, you guys. So a couple things that I want you to remember about arithmetic and geometric sequences. Mainly some of the big differences that we do. First thing I'm going to do is just give you an example of an arithmetic sequence. So, for instance, maybe something like 2, 5, 8, 11, and so forth. And then maybe a geometric sequence, we could do something like 3, 6, 12, 24, and as it continues. And so we talked about a couple things. One of the first things I wanted you guys to be able to do, I heard a lot of, when we were doing work time, I don't remember how to do this. I don't know what to do. But really, the first thing that I would do if you are completely lost is I would attempt to find my common ratio when dealing with geometric, and I would attempt to find my common difference when dealing with arithmetic. And so in this case, this one's a little bit easy to see. 2, 5, 8, 11. Most of us can probably look at that and say we're going up by 3. However, whenever we had our fraction problems, whenever we had our decimal problems, when we were, going up by a negative, when we transitioned from a negative, number to a positive number in the sequence, it became a little more difficult. But something that works every time to find your common difference is we can take the second number and subtract the first. So 5 minus 2 equals 3. We can take the third number and subtract the second. 8 minus 5 equals 3. We can take the fourth number and subtract the third. All of those give me 3. So this is how to find your common difference. It's a difference because we subtracted to get it. And it's in common because they're all the same. If one of these didn't match, then you don't have a common difference, and it is not an arithmetic sequence, in which case you could check and see if it's geometric. So with geometric, the only difference is, if you recall, we're trying to figure out, well, what do we multiply by as we go up? So 3 times 2 gives me 6, times 2 gives me 12. So we can kind of see that that one, once again, is times 2. However, whenever we started dealing with fractions, especially on that quiz, a lot of people got those wrong. And so we need to make sure that we have a method of using to be able to use in order to find the common ratio as well. So to find the common ratio, just like up here, we're trying to figure out what we add by, so we do the opposite with our terms and subtract. Well, right here, we're trying to figure out what we multiply by, so we do the opposite and we divide. Second term divided by first term. Third term divided by second. Fourth term divided by third. And all of those match. Since all of these match and they give me a 2, then that's how you find your common ratio. So as you're working today, the first step you should take if you're confused is to decide, is it arithmetic or geometric? Well, you need to know, does it have a common difference? If so, we know it's arithmetic. Does it have a common ratio? If so, it's geometric. If it has neither, so you've done this process where you subtracted and divided and none of them are common, then it's a neither situation. It's not arithmetic. It's not geometric. Another couple things I want to mention about these are just some of the big differences. Right, first off, your formulas. Your explicit formula for an arithmetic sequence, a sub n, the term you're looking for is going to be equal to your first term plus your common difference times your term number minus 1. And so remember, you would have to distribute in this case, and so I'm going to put that over here that you're going to have to distribute. When you do the explicit formula for the arithmetic. If you do the recursive formula for arithmetic, don't forget that you have to announce what your first term is. You have to give it a starting point. A lot of y'all forgot to do that on the quiz. In this case, our formula is going to be the term we're looking for is equal to your previous term plus your common difference. So there's your recursive. In that case, we don't have to distribute. All we're going to do is plug in for our first term. We're going to plug in for our common difference. All right, let's go down here and talk about your formulas for geometric. Your explicit formula for geometric is going to end up being a sub n, or the term that we're looking for, is going to be equal to a sub 1 times your common ratio raised to the n minus 1 power. Right here, notice we don't have to distribute anything. We're plugging in our first term. We're plugging in our ratio. So you put a 3 right there. You put your 2 right there. And then you're finished. Right? So that's explicit formula. If you were to do your recursive formula, once again, give it a starting point. But then whenever you write your formula, a sub n equals your ratio times your previous term. So the term you're looking for equals the ratio times the previous term. This is its own entity. It's called the previous term. So you're not going to plug anything in. I saw a lot of people that were trying to plug stuff in for A and plug stuff in for N when we were doing that. You're not plugging anything in for that. So don't do that. Some of the ways to recognize quickly, should I test if it's geometric? Should I test if it's arithmetic? Remember, we talked about some things to look for with this. It's that numbers get big fast, or numbers get small fast. And so I'm going to put numbers get big / small fast. We can look at these numbers, 3, 6, 12, 24. The next one will be 48. The next one will be 96. I mean, they're getting a lot bigger than these are. Your arithmetic sequence is going up by that constant, right? Unless that common difference is something like 100, you're not normally going to see those numbers going up really fast. So that's a good thing to, not saying that it'll always work, but when you see that, you should probably first check geometric by doing this process over here in orange. And then if it doesn't work, go to your arithmetic and check that next. But so a couple big things that we, differences, we distribute when we deal with arithmetic and the explicit formula. We don't have to distribute down here. Don't forget, whenever we plug in, that whole plug-in method that we were talking about, in order to find the 50th term or the 100th term, you're going to plug in to the explicit formula. We don't plug in, at least not for our n value. We do plug in for our ratio. We do, substitute for our first term, but we're going to plug into the explicit formula to find a specific term. So if you're looking for the 100th term, you're plugging in 100 for n. If you're looking for, the 50th term, you're plugging in 50 for n. So keep those things in mind. So today you're going to go ahead and you're going to be working a similar practice that we've already done, but you're going to have to be able to distinguish between arithmetic and geometric sequences. You're going to have to be able to find your explicit formulas and your recursive formulas. You're going to have to be able to convert. Don't forget that converting isn't crazy. The only things that you need to be able to write either one of these formulas for arithmetic is you need your first term and you need your common difference. Down here, you need your first term and you need your common ratio. If you can have those two things by doing this and by looking, then you got it. So today you're going to be working on those things. Please make sure you get to the word problems. Don't freak out about the word problems. Pull out the information that's needed. Be able to try those, because those will also be on your test. All right. Good luck. I will see you guys tomorrow.